Hello, and welcome to this panel session to discuss how Cisco is enabling organizations to bridge data center and campus and branch networks to deliver future-ready AI environments. Now, today we're joined by Cisco experts Murali Gandluru, Vice President of Product Management for Data Center Networking, and Matt Landry, Vice President of Product Management for Cisco Wireless. Welcome, gentlemen.
Good to be here.
Great to be here, Bob.
Yeah, absolutely. I'm looking forward to this discussion. As I was thinking about it, as AI adoption is really starting to accelerate, the networks across both data centers and distributed environments are really under pressure to evolve. There's the training workloads that are driving massive scale in the data center, while inferencing and agentic AI workloads are increasingly shaping all the traffic at the edge, campus, and branch. So the challenge and the corresponding resulting opportunity then becomes that ability to build a cohesive cross-portfolio strategy that unifies these domains while addressing the unique requirements for performance, reliability, and agility. So I'm looking forward to this panel as you're able to share some of the lessons you've learned from early adopters, the ability to explore how AI inferencing is really reshaping the design and operations, and discuss some of the best practices for creating that future-ready AI networking strategies. And I think we'll also explore how Cisco's unified edge vision brings these worlds together, enabling the enterprises to determine where the workloads should reside as well. So with all that said, why don't we get started? And the first question, I'll throw it out, Murali, you can start, and we'll go to Matt afterwards. But can you talk about what you're seeing, some of the challenges of these early adopters of AI networking, what they're facing, and what advice you would give to these organizations that are considering having this cross-portfolio approach as they plan for the future?
Thank you, Bob. What we're seeing early adopters of AI hit are pain points, particularly around scale of their infrastructure, power considerations, cooling considerations, all of that infrastructure stuff, but also very importantly, operational complexity. As you might imagine, networks have not been built or designed for GPU to GPU class of communication, not just from the volume of traffic, but also the kind of patterns that they expect in terms of the network profiles. So those traditional workloads and how they would move across the fabric, and especially in the data centers, is different. On top of that, the management of those networks, the back-end AI networks and the front-end AI networks, storage, management, it was always designed where the front end was the biggest part of the network. Well, actually, right now, a back-end is vastly outstripping, especially in some of the bigger enterprise environments. So that brings with it automatically, and the scale, security-related issues, networking issues, of course, which I described, but also observability across all of these paradigms. So what we would say is that when organizations are thinking about it from a cross-portfolio approach, I was just talking about the data center, and as we get into the campus branch, you want to have an approach that's scalable across a few paradigms. One is the principles of securing your infrastructure across all of these environments, the ability to have a common approach to observability and the actionability across these. That is something that has helped some of our customers as they went and deployed GPU clusters, not just across one data center and front end and back end, but also across multiple sites as well.
Yeah, no, I think that makes a lot of sense. And certainly I'm hearing more and more about those multi-data center GPU clusters and things like that as power requirements crop up. So it's certainly something that organizations need to think about. Now, Matt, you have a little bit of a different perspective. You're coming from that campus and branch side. You're seeing some of the impacts of inferencing. What can you share with our listeners?
So we think about it collectively at Cisco, and what we just heard Murali go through is a lot of the elements of what we would call AI for networking, or networking for AI, as opposed to AI for networking. And so in the campus and the campus and access networks that we build, there's a lot more focus and need for the AI for networking, because the fundamental design of the networks hasn't had to evolve, because the 2 or 3 tier kind of switching and wireless connectivity that persists. But what we see are two things. We see the activities of the users on the networks evolving as they're adopting more AI tools, consuming more of that inferencing type of use cases. The traffic patterns are evolving because of that, away from the sort of traditional static web page load and wait while the human reads. Instead, it's a lot more interactive and continuous flow of data. We're seeing a lot more users, quote unquote, users on the network, and these tend to be more machines now. They're agents that are on the network, and they kind of look and act like humans, even though they're not. They're machines, and thus more sensitive to latency and able to make use of higher bandwidth. And then we're also seeing the needs for a lot of the operations teams that are running those campus networks just because of the standard business constraints we all face. Do we have enough personnel? Can we scale up our budgets in order to hire in more? And the answer is always no. So they're looking for tools to help them operate their networks and keep them in tip-top shape. And so we need a lot more automation in the networks. And that comes by way of agentic operations inside the management platforms, or it comes in the form of tools that can help accelerate any sort of troubleshooting in a case where the network isn't able to heal itself. So there really are these two different approaches to where AI plays either in the network or for the network, that both Murali and I get to see both sides of that. And then that comes together with the security questions and the common policy when we want to connect data centers to campus enterprise networks.
Yeah, I think that makes a lot of sense, and it's I think it's good food for thought for organizations that are listening to make sure that some people have, is it networking for AI, AI for networking? It's both, right?
Yep.
And the reality is that you need to consider both of those, especially, and it's not just a data center issue; it's also a campus and branch issue. Uh, and that really leads me up to one of my next questions, and we can start with you on this one, I think, Matt. Um, how do you see the adoption of AI inferencing influencing some of those traffic patterns, the network design, and also how does that impact the day-to-day operations across the data center and campus branch environments?
It's a good question, a good topic, because it really kind of emphasizes the continuous connectivity. We are always connected. Our users, we've gotten used to mobility so that we're able to move around our environment, but we need to have a solid data connection at all times because we need to access a lot of these AI tools that are supporting us as individual workers. They tend to be hosted in the data center or somewhere in the cloud. And so we need that constant connectivity. If you could imagine sitting there and having a conversation with an AI, you need to have a constant real-time connection in order to make that effective for you. But we're also seeing a lot more adoption, when it comes to AI. What are some of the use cases? Autonomous guided vehicles or mobile robots, right? The adoption of those is going up dramatically. And those are, fundamentally wireless, which has a much more challenging type of medium to manage for the network. And that's where some of those support tools are most important. One
Yeah,
of
I
the
think
things I see customers grappling with is really not being comfortable with the fact that they don't know yet what is the full host of use cases they're going to have. And we all come back to in these conversations, it's changing so rapidly when the customer is designing a network and making a decision to upgrade. They really need to be thinking about the future and not just about the past. And so planning for machine to machine interactions and human to machine interactions is the one thing they can be certain is going to grow more and more in the future.
Yeah, and I think that's such a key point. Some of the takeaways for me from that, one is that all of this is additive.
Yeah.
Organizations still have all their mission critical apps, all their apps for their daily operations of their business, and now they're adding all of this on top of it. So that's something that they certainly need to make sure they're taking into consideration as they're building all this out. Murali, from a data center perspective, what are you seeing?
I'll start off where you left it, which is about the additive nature, and that's absolutely true because um, in the data center, as I was saying earlier, the front end of the network used to be or has been traditionally the biggest part of the network, and so essentially you have a lot of servers, CPU to CPU communication, CPU to storage, there's a certain traffic pattern and paradigm that's been built. You've built network overlays with it, and you had, all of the VXLAN EVPN fabrics or SRv6 fabrics, all kinds of network architectures. One of the key things that has changed now is that uh, what's required and expected of the systems is the ability to have mixed workloads, hybrid workloads. So the ability to have both CPU and GPU environments. Some of our customers have actually deployed with a mix. And what that tells in that moment, then the network ops team has to make sure that the priority is given for the higher probably priority GPU to GPU communication versus the CPU to CPU communication or CPU storage, right? So how do you do that? If you could do that natively at ingress, um, in your network fabric, while being able to provide regular load balancing and other kinds of capabilities for the CPU traffic versus the GPU traffic, if you can deliver that, that would be a differentiated value. And that's where Cisco has always believed in the differentiated value of silicon. And so these are some of the things that operators are facing. And then how are you able to then, when there is an issue coming to the AI for networking piece, how can the operator quickly hone in on where a particular problem lay, right? So essentially, that is something also that's important, being able to quickly hone in on which part of the fabric link is overheated, or there's a particular optics that's gone over the temperature threshold, being able to root cause things quickly as well. These are things that are much more complex, and when you go across data centers, it's even more when you think about multiple inferencing sites and locations. So that's why the NetOps teams are so much under pressure.
Yeah, I couldn't agree more. And it's certainly something we hear consistently. The environment, as it's become so much more distributed, right? It's the applications are distributed across data centers, across clouds, across the edge now as well. So the network is the one piece that really ties it all together, and it's becoming far more important. I think in our last research we did, 93% of organizations said that the network is far more important now for achieving their business goals.
Yeah.
And it's so true because of all this distributed nature, let alone all the workers, right? And forget the apps, all the workers are distributed as well. And the places where you're going to be collecting data are going to be distributed. So again, that network's going to be super important. And it really needs some thought that needs to go in for that design and so forth to ensure it's going to achieve all the objectives.
I like to think about, as a bit of an analogy. I like to think about the modern kind of pipeline factory, right, where you have many different products at various stages of completion, and if something goes down, then that whole factory line shuts down. And that's very similar, although now it's all about parallel processing, right? So in the data center, you have a lot of parallel workers doing a lot of work. You have a lot of, us as knowledge workers that are interacting with different AI tools, and we're all doing it at the same time. So it's not a one factory line. But if that problem shows up inside the data center and we can't figure out what the cause of it is, then everybody goes down, and it's very painful for organizations. So it really emphasizes the need, in order to keep operations running, because we are dependent on these tools, that we need to find and fix problems as fast as possible.
Yeah, and that actually ties in nicely to what I want to talk to you about next, because I know one of the key themes for Cisco has been around digital resilience. And so when it comes to reliability and performance, I'm wondering if you can share some of the top priorities you're hearing from customers and how AI is actually helping them address that. And so, Matt, I guess we'll start with you on this one.
Sure. Yeah, and I'll maybe call back to some of the comments we made earlier, where it's really about our customers scrutinizing the OpEx that they have available to spend on running their networks, or in particular to focus on help desk and break fix type issues. And the fact is, they want their people working on things that benefit the business very directly in terms of returns, and don't want to spend as much time on fixing things that break. And the reality is, yes, things go wrong on networks, but the more that we, as the network equipment vendors, can automate those fixes, or make the network or the designs fundamentally more robust, is what helps our customers get that sort of either OpEx savings or help them weather reductions that they have to deal with. And so all of them come to us and want to talk about what sort of tools, particularly in the management platforms, can we provide that will help make them more efficient, more effective, and in the end, keep the network up and running so that that factory line never shuts down.
Yeah, and if I could add, one of the things about, to your point, one of the things about performance and reliability, we on the infrastructure for AI side or the network for AI side, we tend to think about the speeds and feeds element of it typically, right? Of course, that's very important. What's also becoming a high priority is the actual infrastructure itself, the power and cooling required. We're talking about some serious wattage that's being drawn out of these servers for sure. I mean, and then also networks nowadays. So being able to come up with innovative technologies like liquid cooled switches. I mean, we showed this at Cisco Live and at GSX as well, where we have our top of the line switches now with liquid cooling capabilities in them in alignment with server racks that are liquid cooled as well, because it's very important to be able to fit within a particular envelope. Otherwise, you have other kinds of consequences of overheating and so on. So that's one piece. The other thing I'd say is that you want predictability at scale. So you want your network to be able to operate in a predictable manner as things scale out or even scale up designs as well. And so being able to predict what latency you have between workload communication paradigms, that's another priority. The third one I would say is something that both Matt and I talked about, which is about security. So far, we've always thought of data center architectures, and for that matter, cross domain architectures with security, at least on the network side, with security as bolt on elements. But now with AI, we're talking about secure AI factories, which means that, or secure AI pods or secure AI factories, smart infrastructure is security has to be infused into that. And it has to be infused into it for the AI paradigm and the non-AI paradigm. So that's the third priority, as I would say, on the infrastructure side.
Yeah, and I'm so glad that you brought up that security aspect of it, because that's always been the classic. Do you want your network to perform or do you want it to be secure? And it
Yeah.
was a either or. It either performed or it was secure, and you couldn't have both. The reality is today that's no longer an option for that to flex up or down. It must perform and it must be secure. And so lots of opportunities. Again, we've just got to the point where the environments are so much more complex and so sophisticated that you need to really leverage. That's where that AI technology can come in to be able to spot all those anomalies that are happening across the network or across the environment and be able to quickly spot that. So it keeps you secure, but also allows you to operate at a very high level of performance.
And those AI empowered tools to help the security teams make sure that the network design is as good as it can be. There's another side to that as well, because the nefarious actors are using AI as well, and AI is really good at finding chinks in armor. Very, very good at finding any little gap in the defenses, and that speaks directly to Murali's point about security fused into the network, because that's the only way that you have a chance of building a network that is secured end to end, and you've filled in all of the gaps and risk points because you are deliberately enforcing security with the same policies at every point in the network, because that's where the gaps usually come up, right? You've got different policies from different teams for different parts of the network, and those create opportunities for bad guys to get in.
Right, absolutely. So taking advantage of like the HyperShield, where you can distribute the firewalls to wherever you need them. Absolutely. I think that makes a ton of sense in today's modern IT and application environments. You had brought up a while back, Matt, a couple questions ago, or your answer, I should say, you were talking about the different use cases, and it made me start thinking about, you know, the different use cases per vertical and per industry and things like that. So I'm wondering if both of you, and we can start with you on this one, Murali, if you could share how Cisco AI networking is enabling some new innovative use cases, or maybe solving some real world challenges for your customers, for your partners across maybe different industries?
Absolutely. We are seeing use cases come across the entire spectrum of the enterprise or business and paradigm. If you think, for example, about quants, the quant industry, they know exactly where AI is going to help them. They want to extract insights that can differentiate them versus their competitors in the financial services market, be able to differentiate that with value to their clients and customers. So what we're seeing is that they're going on a massive build out of their AI infrastructure. And we know exactly the kinds of use cases and traffic patterns that they expect. They want to be able to simplify their operating paradigm by having similar kinds of uh, solutions across the front end, the back end, and also in some cases, certain remote environments as well. Another example I'd give is where inferencing and RAG use cases become even more important is around the example Matt brought up earlier. We have a customer that's deployed over 16,000 GPU clusters in the back end with Cisco for autonomous vehicles. And those use cases are for the factories, for the autonomous vehicle factories, where they have to drive a lot of insights locally, right? Instead of going to a central environment only. So this, and then there is, of course, the whole sovereign cloud and neo cloud paradigm, which is about servicing enterprises. So they're looking at how can I build multi-tenant infrastructure? How can I build it secure? How can I make sure that there is pre-validated stacks that I can go quickly deploy? That's where AI pods kind of architectures from Cisco really help them, and you go and deploy them as well. So we're seeing a number of new use cases, both from the core and context of a business, but also from how those businesses are themselves are evolving as well. So it's a really fun time for AI networking.
Yeah. Yeah, I see a lot of parallels too in the way, we have been, particularly with the wireless team, we have been working with people to get mobile, to untether themselves from a wired connection inside the campus or branch. And this still continues today because, especially with Wi-Fi 7 having entered the market and really focusing on improving the reliable connection, the noise tolerance so that you can get more devices on wireless communicating at the same time and not stepping on each other, that demand for taking things that used to be wired and making them wireless continues. Just an example, I was talking to a customer who's working in a movie studio, and they would sit down with a 3 or 4 monitor doing 8K video production editing. You can imagine high frame rate, explosions and movement, and that sounds like a wired use case, right? But turns out no, actually the folks want to get mobile. They want to be able to move those workstations around, get closer maybe to the actual production sets in order to make changes. So now all of a sudden you have something that everybody thought had to be wired, now moving to wireless. This is a long way to draw a parallel to AI tools because it's a case where you can take workflows and problems to solve that you did with just human ingenuity before, or you did with elbow grease, and now you've got a new set of tools that you can now automate it and accomplish the same task you wanted to in a much different way, much more efficient way, and now that lets you think differently about what challenges to next address.
Excellent. Yeah, I think that makes a lot of sense. I'm going to put you guys on the spot now. I'm going to ask you what you see some of the biggest similarities and also the differences in AI networking requirements between the data center environments and the campus and branch locations. So I guess we're going to start with you, Matt, on this one.
Okay, so this is a good one, and you're implying, by the way, Bob, that everything would be before this was scripted, and I can assure you that we were all speaking off the cuff here. But I think one of these similarities that comes to mind just has to do with the quick on, quick off nature of the workloads, and we see this with wireless connectivity in particular, and the types of traffic that users are generating, where we want maximum throughput and minimum latency to get on the network and off the network as fast as possible and free up space for somebody else to do it. And the more you can do that, the faster you can do that, then the more devices and people you can have communicating on the network simultaneously. And so I see some similarities with that to the way that workloads are set up and torn down in the data center. And now Murali can either agree or tell me that I'm full of it.
No, actually, I agree with you. That is absolutely true. On the similarities, if I double click on the point you just made, we could extend that further into of course, the data center, but also into the campus environments, not just on the wireless side, but also on the wired side as well. We're seeing the demand similarities from, predictable latency, strong security, which we've already discussed earlier, the ability to have seamless observability across these environments. There's a lot of similarities in in these architectures. What I also see is that one area where I think maybe, and I'd love your feedback on this, is uh, data centers are very bandwidth intensive and um, east-west traffic intensive, optimized for GPU communication. But is we were you saying also that in the campus probably it's more that these AI applications are driven at the edge where there's distributed sort of endpoints, or would you say that that's a
Yeah,
difference area of difference?
Yeah,
yeah,
that's changing, right? That's evolving as well because there has been this push to just focus on north-south traffic
Exactly.
that leaves the campus and goes out to the public internet and back. And of course, that's still there and growing, and there are technologies to support that. But this level of autonomy and the availability of, maybe smaller format data centers or compute that can be located on premises with very useful tools to put into those compute workloads, we're seeing a lot more increase in east-west traffic without even touching on the IoT topic and IoT devices that are on there.
If I could just add one thing, Bob, before we move
yeah.
on. If you see the similarities and the differences, right? That's where Cisco announced a few innovations. Most importantly, something called AI Canvas, which allows us to look at this end-to-end cross portfolio, cross domain. We're able to look at how a particular user comes in to access certain assets, be able to see what kind of paradigm is happening inside certain within each domain. And so being able to visualize that, be able to quickly point to where a particular issue could be, that's a fundamentally different way of how we are building out infrastructure now. And so that's a watch out for that innovation that we've kind of highlighted both at Cisco Live and afterwards as well, which touches both Matt's domain all the way across to the data center domain as well.
Yeah, and I think that's obviously going to be hugely important for organizations who are trying to manage their end-to-end environment. So having a single, we'll call it for lack of a better word, tool that enables you to have that coverage across the data center, across the campus and branch, and provide the context of what's going on is really going to help them manage it more effectively and drive a lot of operational efficiency. Because I think one of the other things you didn't even bring up is that with the canvas, you also have multiplayer capabilities.
Yes.
So you can very quickly and easily get your counterparts from the campus side over to the data center side and the security team, et
Very
cetera.
collaborative.
So they're all collaborating on getting this back up and running. Yeah, and that's a great example of how AI for networking is really being able to pull together and providing that kind of comprehensive visibility and management of those overall environments.
Bob, I love multiplayer. Calling him, that's great. That's great. Can we turn that into a
Gaming.
term of art if it's not already for the industry? That's great.
Yeah, I think we're heading there. I've heard it mentioned a couple times now, so I think that's going to be something we're going to hear more about. I think just like closed loop went to human in the loop, right? So I think we're starting to get a whole new vernacular as AI starts to permeate the networking environment. So I'm all for it. I think t-shirts are next.
Yeah.
Multiplayer, multiplayer AI. Um, Obviously, we've talked a little bit about the whole concept of, right now, certainly for the enterprises, they're rolling out their AI data centers, they're building them out, but we're also starting to see more of that shift towards inferencing. We're starting to see some of the agentic workloads that are driving more of that machine to machine communication. We touched upon that. So as we're wrapping up here, what kind of cross portfolio considerations should organizations keep in mind so that they're able to build a cohesive, future-ready AI networking strategy for their organization.
Yeah, and I could take it, Bob. I think as we were just talking about it, unified operations doesn't mean same, but it means unified in complete construct across all of across the complete infrastructure paradigm, LAN, WAN, wireless, data center, and so on, with that common tool and a common approach, philosophical approach, would be a key important piece. The other important piece that we both touched on was around infusing security. We've got to make sure that instead of hairpinning traffic to a centralized location where all security is done, be able to make sure that every workload, every packet, endpoint is protected by architectural design itself, right? As close to where it enters or where the malicious actor enters, right there. Observability, being able to see things. I mean, since I know you just come from .conf, but observability, AI driven telemetry, be able to drive insights and be able to then provide that back into other domains is going to be an important element as well. Then finally, I mean, I would think that from a data center perspective, we're going through a very interesting paradigm right now about scale up versus scale out. That's a whole topic by itself. How do we deal with these architectural changes and make it much more machine to machine as these designs, all the workload communication happens, how we push policy across these environments? That's the fourth pillar, is what I would say, scale.
Yeah, I would add on to that. This idea of observability is particularly important for customers who are building out data center capacity, because the workloads, the AI workloads there are not as tied to offline compute, batch processing that happens in the background and then you come back to it later. Instead, it's a lot more interactive in real time, which means having the observability from the employee to the workload is critical. If there's no visibility and something goes wrong, you have that factory line go down. So that's a big one to really focus on. The other, maybe piece of advice that I would share, because I see a lot of customers struggling with this, is they're often coming into a network refresh or redesign, thinking about the workloads they have today, thinking about the user base they have today, and not immediately thinking, no, we need to be planning ahead. We need to think about, hey, we all talk about large language models today and kind of think of that as the example of AI workload. Small language models are a big deal too, and we're going to see those spread out a lot more diffusely throughout the organization, which is going to bring a lot of that same AI traffic to much smaller devices, much more frequently. And so we are going to see an effective explosion in the number of actors on the network. And so anybody designing a network today needs to think about, what is it going to look like 5 years from now? It is not going to be what we're seeing today. It is going to be very, very different. And if you're making the investment today, you should plan for the future.
I
Absolutely.
think that's great advice. I think especially as I heard at the conference last week that I think more than half of the data that's going to be generated will be coming from machines. So when you're starting to think about what's going to be coming down the road, I think it's really going to be prudent for organizations to be considering that as they think about how they design their networks. So listen, I appreciate all of your time. Unfortunately, we are limited, and so we're going to have to get moving on. But I definitely want to thank both of you for joining me today. This has just been hugely valuable perspectives on AI, how it's transforming networking across data centers, campus, and branch environments. So thank you, gentlemen.
Thanks, Bob.
Thank you. Thank you so much for the opportunity.
Yeah, absolutely. And for our audience, the key takeaway is that AI networking is going to require a holistic approach that blends performance, reliability, security, and intelligent operations across every part of the network. So thank you all for joining us, and stay tuned for more Networking for AI Summit.